Hello students, let us try to understand the postulates of molecular orbital theory. As you can see here, it has been given by two persons, Hund's rule which you study, and Millikan in the year 1932. It is the same year in which neutron was discovered. So let us go through the postulates one by one. So first postulate says the electron in a molecule are present in the various molecular orbitals as the electrons of atoms are present in the various atomic orbitals. So here you have to understand that the moment a molecule is formed, the atomic orbitals they get converted to molecular orbitals. So what is the room for the electrons? The electrons no longer reside in the atomic orbitals now they reside in the molecular orbitals. Now next point, the atomic orbitals of comparable energy and proper symmetry combine to form molecular orbitals. So here it is a very important point and it is a major difference with hybridization. You see, in hybridization you know that orbitals of the same atom undergo mixing, and that also only the valence orbitals of the central atom usually undergoes mixing. But in molecular orbital, whatever the atomic orbitals of the combining atoms are there, all the atoms they combine together to form the molecular orbital. This is a major difference with hybridization. Third point, while an electron in an atomic orbital is influenced by one nucleus, in a molecular orbital it is influenced by two or more nuclei depending upon the number of atoms in the molecule. So here again a very important point. You know that when we are talking about an atom has one nucleus and all the electrons belonging to that particular atom, they are under the influence of one nucleus. But when molecular orbital forms, then as you know a molecule requires minimum two atoms. Say if I say hydrogen molecule, then hydrogen molecule is represented by H2. That means it has two atoms. Now each hydrogen will have one electron in the atomic state. But when they form the molecule, then each electron will be under the influence of two nuclei. Similarly, if you have water will have how many atoms? Water will have three atoms. So these three atoms will be under the how many electrons in water then? Oxygen has 8. Each of the hydrogens having one electron. So altogether there are 10 electrons. Now all the 10 electrons will be under the influence of three nuclei, one oxygen and two hydrogen. That's why it is said molecular orbitals are polycentric, not monocentric, polycentric, whereas atomic orbitals are monocentric, meaning mono means one, centric means center. So atomic orbitals having one center, that is the nucleus, so monocentric. Molecular orbitals have many nuclei depending on the combining atoms, so they are polycentric. Now comes another point. The number of molecular orbitals formed is equal to the number of combining atomic orbitals. Till here, it is same as hybridization. In hybridization also you have seen as many orbitals combine, that many orbitals form. But you see the next point. It says that when two atomic orbitals combine, two molecular orbitals formed. One is known as bonding molecular orbital, another is called anti-bonding molecular orbital. And in case of hybridization, we know that each of the orbitals are called a particular type of hybrid orbitals. So here in hybridization, all the orbitals formed are of similar energy and shape. But in molecular orbital theory, it is said that the orbitals which are forming after combination, they are not same in energy and shape. One is bonding and the other is anti-bonding. Now what is the quality of the bonding orbitals? The bonding molecular orbitals have lower energy and hence greater stability, and anti-bonding orbitals will have more energy and less stability. To understand this, let us have the diagram. You see in this diagram, two atomic orbitals are combining. You can see their energies. This axis represent energy. So these two orbitals have certain energy, and when they form the molecule, one orbital goes to lower energy, that is more stable, less energy, and another goes to higher energy, that is less stable. But total sum of these two orbitals will be sum total of these two, because you know law of conservation of energy has to be followed here. Now you look here, the diagrammatic representation they have given, you can see this is one s orbital, this is another s orbital. If they undergo addition, as we have done LCAO, so you can see here that they form one molecular orbital, that is sigma 1s. In your book, if you check this diagram, there is only one dot. There should be two dots representing two nuclei. Okay, so it is polycentric. Whereas when they undergo subtraction, linear combination of atomic orbitals, which you have done if you remember, there is plus and minus kind of operation. One is plus giving you sigma bond and minus giving you sigma star, that is called antibonding. So in the antibonding orbital, you notice here there are two nuclei. As you can see, there are two dots. Is it very clear? And in the middle, you can see there is a line drawn and the pink color is not there, meaning there is no electron cloud in between the two nuclei. So you can understand the two nuclei are very close to each other and they suffer a lot of repulsion, because of which they are unstable. Similarly, if you have p orbitals undergoing mixing of two combining atoms, one forms sigma 2pz, another forms sigma star 2pz, we consider z as the bonding axis, so sigma bond is formed along the z axis. So when two pz orbitals combine by addition operation, you can see the total electron cloud here. You can see at the center the electron cloud is maximum. By combining two dumbbells, the central part becomes very electron rich, and these two dots, as you can see, these represent two nuclei. Whereas when they undergo repulsion, negative operation, you can see here the symmetry also you must see, minus plus minus plus. Okay, and in between there is a nodal plane when there is no electron. So sigma star is very, very unstable. Similarly, as you know, there are p orbitals are 3 in number. If one is forming sigma, the other two has to form pi. So if I assume that px orbital is forming pi bond, and pi bonds are formed by lateral overlapping, so they also undergo addition and subtraction. By addition, you can see the 2 plus they get added up and form 1, and the 2 minus also get added up and they form 1, and there are again two nuclei here, you can notice. Okay, and if it is undergoing negative operation, you can see here that there is a nodal plane again, and please check the symmetries, minus plus minus plus. It looks like a butterfly, isn't it? So that's how the bonding MOs are more stable than the antibonding MOs. Next point. Just as the electron probability distribution around a nucleus in an atom is given by atomic orbitals, the electron probability distribution around a group of nuclei in a molecule is called molecular orbital. I hope you remember when you have studied definition of atomic orbitals. How did you learn? It says that it is the region around the nucleus where probability of finding an electron is maximum. And here it is the region around the nucleus where the probability of finding it is a region around the nuclei where the probability of finding an electron is maximum. That can be defined as the molecular orbital. Last point, the molecular orbitals, just like atomic orbitals, are filled in accordance with the above principle. That means they also have energy levels, like as you know, 1s, 2s, 2p, they have the energy levels. So here also we have sigma 1s, sigma 2s. I have given you the energy levels already, so you can check that. They also follow Pauli's exclusion principle. What is Pauli's exclusion principle? That means when the electrons are occupying the same orbital, they will not have all four sets of quantum numbers same. In other words, they will have opposite spin, and they will follow Hans rule. That means if we have orbitals in the same energy level, then the orbitals will be filled up first singly and then they will pair up. So this is about the postulates of molecular orbital theory. If you have any more doubts, you can ask. If I have missed out any point, you can please clarify.